This business of n choose k has to do with starting with a set and picking a subset of k elements. Another way of thinking of that is that we start with a set with n elements, and you choose a subset that has k, which means that there's n minus k that are left. Picking a subset is the same as partitioning our set into two pieces. Now, let's generalize this question and start counting partitions in general. Somebody gives you a set that has n elements. Somebody gives you also certain numbers, n1, n2, n3, let's say n4, where these numbers add up to n. And you're asked to partition this set into 4 subsets, where each one of the subsets has this particular cardinality. So you're asking to cut it into 4 pieces, each one having the prescribed cardinality. In how many ways can we do this partitioning? N choose k was the answer when we partition in 2 pieces. What's the answer more generally? For a concrete example of a partition, you have your 52-card deck, and you deal, as in bridge, by giving 13 cards to each one of the players. Assuming that the dealing is done fairly and with a well-shuffled deck of cards, every particular partition of the 52 cards into 4 hands, that is 4 subsets of 13 each, should be equally likely. So we take the 52 cards and we partition them into subsets of 13, 13, 13, and 13. And we assume that all possible partitions, all possible ways of dealing the cards are equally likely. So we are again in a setting where we can use counting because all the possible outcomes are equally likely. So an outcome of the experiment is the hands that each player ends up getting. And when you get the cards in your hands, it doesn't matter in which order you got them. It only matters what cards you have on you. So it only matters which subset of the cards you got. All right, so what's the cardinality of the sample space in this experiment? So let's do it for the concrete numbers that we have for the problem of partitioning 52 cards. So think of dealing as follows. You shuffle the deck perfectly, and then you take the top 13 cards and give them to one person. In how many possible hands are there for that person? Out of the 52 cards, I choose 13 at random and give them to the first person. Having done that, what happens next? I am left with 39 cards, and out of those 39 cards, I pick 13 of them and give them to the second person. Now I'm left with 26 cards. Out of those 26, I choose 13, give them to the third person, and for the last person, there isn't really any choice. Out of the 13, I have to give that person all 13, and that number is just equal to 1, so we don't care about it. All right, so next thing you do is to write down the formulas for these numbers. So for example, here you would have 52 factorial divided by 13 factorial times 39 factorial. And you continue. And then there are nice cancellations that happen. This 39 factorial is going to cancel the 39 factorial that comes from there, and so on. After you do the cancellations and all the algebra, you're left with this particular answer, which is the number of possible partitions of 52 cards into 4 players, where each player gets exactly 13 hands. If you were to generalize this formula to the setting that we have here, the more general formula is you have n factorial, where n is the number of objects that you are distributing, divided by the factorials, the product of the factorials of the, okay, here I'm doing it for the case where we split it into 4 sets. So that would be the answer when we partition a set into 4 subsets of prescribed cardinalities. And you can guess how that formula would generalize if you want to split it into 5 sets or 6 sets.